The universe is incredibly vast. Naturally, humans have always wanted a glimpse beyond its limits. To answer the question of what lies beyond our universe, we must first understand what the universe actually is. Today, we will explore the structure and the scale of the cosmos, and try to look into the unknown. We will begin our journey with the solar system, where we will admire rare photographs captured by spacecraft. After that, we will leave our star system behind to see what secrets are hidden in the neighboring system known as Alpha Centauri. As we wander farther through space, we will encounter black holes, objects that can not only consume everything in their path, but may also help create entirely new star systems. And finally, we will travel beyond the boundaries of our universe, where we may encounter something extraordinary, an identical copy of yourself. Music. Welcome to space. Let us begin with our own solar system. Today you will discover what temperature exists on the Sun, where an ocean might exist beyond Earth, and which planet hides golden clouds. Our solar system consists of the Sun, a yellow dwarf star, and 8 planets orbiting around it. Of course, there are also dozens of natural satellites, 5 dwarf planets, asteroids, comets, and even clouds of interplanetary dust. Our galaxy is colossal in size, containing hundreds of billions of stars and an even greater number of planets. Yet for a long time, scientists believed the solar system might be unique. Many researchers still describe how unusual it is and continue studying the peculiar features of our planetary system. At the center of this system lies the Sun, our shining star. It sits exactly in the middle of our celestial neighborhood. In many ways, the Sun is surprisingly unusual, which is why scientists have studied it for decades. Our star is roughly 85% brighter than many other stars in the Milky Way. The temperature on its surface reaches around 5,700 degrees Celsius, or about 10,300 degrees Fahrenheit. But here is something curious about the Sun. Logically, the temperature should rise as we move closer to the surface layers. Yet the Sun does not follow that simple rule. The hottest region is actually the core, where temperatures reach roughly 27 million degrees Fahrenheit. This mystery has puzzled scientists and professors for many years. Thanks to modern spacecraft photography, we can now see the upper atmosphere of the Sun, known as the corona. On its surface, you can also notice dark filament-like structures stretching outward. These are called solar prominences. They appear as enormous arcs and clumps of plasma, twisting into various shapes before ejecting huge amounts of coronal gas into space. These eruptions create powerful storms in the solar wind. Yet even these prominences are not fully understood. Sometimes they break away from the surface of the star and send massive clouds of plasma racing through the solar system. Such events can disable satellites orbiting Earth, disrupt communications, and even threaten the crew of the International Space Station. They also trigger powerful magnetic storms that interfere with radio signals and can even affect human sensitivity to weather changes. But this is not what scientists fear the most. The greater concern is that one day a prominence could grow large enough to release an enormous burst of solar material, powerful enough to threaten life across our planet. The spacecraft also captured several images using an instrument called the SPICE tool, which observes the Sun in ultraviolet light. With it, scientists can identify different layers of the solar atmosphere, from the corona down to a region called the chromosphere as it approaches the visible surface. In these SPICE images, each color represents a different element and temperature. Purple corresponds to hydrogen gas at roughly 5,500 degrees Fahrenheit. Blue indicates carbon at about 17,700 degrees Fahrenheit. Green marks oxygen at approximately 177,000 degrees Fahrenheit. And yellow represents neon at nearly 350,000 degrees Fahrenheit. According to NASA scientists, This is only the beginning. The spacecraft will fly close to the Sun many more times, approaching from different angles. It may even pass over the Sun's polar regions, areas that have never been directly observed before. And now, let us talk about the planets. Mercury is the first planet in the solar system. It orbits approximately 36 million miles from the Sun and is the smallest planet in our planetary family, only slightly larger than Earth's moon. Because it is so close to the Sun, its surface temperatures are extreme. During the day, they can reach around 800 degrees Fahrenheit, while at night they can fall to roughly negative 310 degrees Fahrenheit. The first detailed images of Mercury were captured by the automated spacecraft Messenger in 2008. It became the first spacecraft to orbit the planet and continued studying Mercury until 2015, when it eventually ran out of fuel and crash-landed on the planet's surface. In videos created from thousands of these images, you can see rays of debris spreading outward from massive impact craters. Some of these rays stretch across nearly the entire surface of the planet. In many ways, the landscape of Mercury resembles that of our Moon, covered in countless craters formed over billions of years. And in one of the most beautiful sequences captured by spacecraft, you can watch the small rocky world of Mercury passing silently in front of the enormous blazing disk of the Sun. The view is both humbling and mesmerizing. Now let us move on to the next planet, Venus. Just as fascinating, Venus is the second planet in the solar system, located about 67 million miles from the Sun. It is often called Earth's twin because it is similar to our planet in both size and mass. But that is where the similarities end. Venus also happens to be the closest planetary neighbor to Earth. It was the first planet to be explored by spacecraft. The surface of Venus was first scanned in 1962. When early missions began mapping the planet using radar technology, one of the most famous images of Venus was captured by the Soviet robotic lander Venera 14. The probe survived on the rocky surface for about 1 hour before the crushing atmospheric pressure destroyed it. The pressure on Venus is about 90 times higher than the pressure at Earth's surface. In the images, we see a rocky desert landscape beneath thick yellow clouds made of sulfuric acid. These clouds trap heat inside the atmosphere and even carry a smell similar to rotten eggs. The photograph was taken more than 40 years ago. Yet scientists continue to digitally process and combine these images today, and the latest analyses suggest something remarkable. Venus may still have active volcanoes. Now we leave this scorching twin behind and move on to Earth, the planet that gave rise to life. The distance between Earth and the Sun is about 93 million miles. What you are seeing now is one of the most famous photographs ever taken. It is called Earthrise. The image was captured from our natural satellite, the Moon. But we will get back to that. The photograph shows the Earth rising above the horizon of the Moon. This famous image was taken by the crew of Apollo 8. The original photograph was captured in black and white. But with the help of modern digital technology, it later became possible to restore color and reveal the scene as it might have appeared to the astronauts. 2 years earlier, another black and white photograph of Earth had already been taken by the robotic spacecraft Lunar Orbiter 1. This footage shows images from the International Space Station recorded in the year 2017. The video was captured during the night side of Earth. We can clearly see the northern lights slowly moving across the sky. The glowing aurora begins over North America and gradually drifts toward the Gulf of Mexico and the coast of Florida. As the station continues its orbit, we begin to see the quiet nighttime beauty of the cities across Europe. Over the Mediterranean Sea, thick clouds are visible, illuminated by flashes of lightning and distant thunderstorms. As I mentioned before, our planet has a natural satellite, the Moon. Its size is about 1/4 of the Earth's diameter, which is unusually large for a planetary satellite. The Moon's gravity influences the tides on Earth. The Moon rotates around Earth while also rotating on its own axis, and these two motions are synchronized. Because of this synchronization, the same side of the moon always faces our planet. In this photograph, you can see the commander of the Apollo 16 mission, John Young. He is waving toward the camera. Nearby, you can also see the lunar rover, the small electric vehicle used by astronauts to explore the moon's surface. This rover set the record for the fastest movement ever achieved on the moon, reaching a speed of 11 miles per hour. Mars was the Roman god of war. Did you know that almost all of the planets in the solar system are named after ancient deities? The only exception is Earth. Mars lies about 140 million miles from the Sun. For many years, scientists believed there might be life on this planet. But so far, no confirmed evidence has been found. At the moment, the Perseverance rover is operating on Mars. It has recently sent detailed images from the surface of the planet. One close-up photograph shows the Martian soil composed of rock fragments and fine red sand. Mars is considered the most suitable planet for future exploration. And perhaps in the near future, humanity may attempt the colonization of another world. The environmental conditions there are relatively manageable, unless of course we consider the complete absence of oxygen and the enormous dust storms that can continue for months. In another photograph, we can see the highest mountain in the entire solar system, Olympus Mons. It rises more than 16 miles above the Martian surface. That makes it roughly 3 times taller than Mount Everest, the highest mountain on Earth. The image was taken by the Chinese spacecraft Tianwen-1 in the year 2021. Among the images captured from orbit were the first detailed photographs of the planet's south pole, where most of the planet's water resources are believed to exist in frozen form. Today, scientists are studying Mars more actively than ever before. Images from the red planet arrive regularly, helping researchers understand the geology and surface features of this distant world. Next in line, we have Jupiter, a gas giant located about 485 million miles from the Sun. Jupiter has the greatest mass of all the planets in our solar system. The picture you see here was taken by the Voyager 1 spacecraft in 1979. You might be wondering about the Great Red Spot visible on the planet's surface. It is an enormous storm system raging within Jupiter's atmosphere, a storm several times larger than Earth itself. In the lower left part of the image, you can also see the moon, Europa. Observations of Europa strongly suggest that beneath its icy crust, there may be a vast underground ocean. Another bright point in the upper right is the moon Io. This moon is so volcanically active that almost no impact craters remain visible on its surface. In another photograph, you can see several of Jupiter's moons, along with a faint ring system. For many years, this ring was only a hypothesis. But in the year 2003, NASA's Galileo spacecraft confirmed that the ring exists and was formed by collisions between meteorites and nearby moons. This image was captured in the infrared range by the James Webb Space Telescope. It was the powerful James Webb Observatory that finally allowed scientists to clearly observe the faint ring structure surrounding Jupiter. In total, Jupiter has 4 large primary moons known as the Galilean satellites. They are Io, Europa, Ganymede, and Callisto. The first moon, Io, can be considered one of the most unusual objects in the entire solar system. Volcanic activity on Io was one of the most dramatic discoveries of the space age. Voyager 1 observed 9 active volcanoes on its surface, and additional eruptions were detected between the visits of Voyager 1 and Voyager 2. The plumes from these eruptions can rise more than 185 miles above the surface, ejecting material at speeds of about 1.6 miles per second. This photograph shows a volcanic eruption composed primarily of sulfur and sulfur dioxide. The second major moon of Jupiter is Europa. In my opinion, this may be the most fascinating moon of them all. Beneath its thick icy crust, there is likely an ocean that may contain more water than all of Earth's oceans combined. In theory, this hidden ocean could have supported life for extremely long periods of time. Ganymede is the largest moon in the solar system. It is even larger than the planet Mercury, and also larger than the dwarf planet Pluto. Ganymede is the only moon known to possess its own magnetic field. something normally found only on full-sized planets like Earth. This magnetic field creates auroras, glowing ribbons of energized gas that appear near the Moon's polar regions. Images taken by NASA's Juno spacecraft on June 7, 2021 provided new insights into Ganymede's surface. Scientists observed craters, contrasting dark and bright terrain, and long structural formations that may be related to ancient tectonic fractures. The last of the Galilean moons is Callisto. This photograph was taken during the 1990s by the Galileo spacecraft. Its surface is covered with countless impact craters. Bright white patches can also be seen scattered across darker regions. And these bright areas are most likely exposed ice. These images are truly mesmerizing. And in the future, we will continue receiving more detailed views of these distant worlds. Next, we move to one of the most visually striking planets in the solar system: Saturn. Scientists believe Saturn is composed almost entirely of gases that become compressed into metallic forms closer to the planet's core. Interestingly, this enormous gas giant has such a low density that, in theory, it could float on water. Saturn is located about 915 million miles from the Sun. This image was taken in the year 2005 by the robotic spacecraft Cassini. The Cassini mission was one of the most ambitious planetary exploration projects ever undertaken. The spacecraft orbited Saturn between the years 2004 and 2017 and studied the planet and its complex system of rings and moons in extraordinary detail. Here we see Saturn's majestic rings appearing as a curved band, partly brown due to their infrared glow. The complex structure of the rings becomes especially visible in the dark shadows they cast across the planet's surface. Saturn's northern hemisphere can sometimes appear partially blue for the same reason that Earth's sky appears blue. Molecules in the upper atmosphere scatter blue light more efficiently than red light. However, scientists still do not fully understand why some of Saturn's clouds appear golden. This photograph, also taken by Cassini, shows two of Saturn's moons, Tethys and Mimas, visible on opposite sides of the rings. Near the top of Saturn, we can also see dark shadows cast by the wide ring structures, revealing how complex this system truly is. In ultraviolet light, the image highlights the delicate textures within Saturn's atmosphere. Unfortunately, in the year 2017, the Cassini spacecraft received its final command. Mission controllers directed it to plunge into Saturn's atmosphere, ending the mission in order to prevent any possible contamination of the planet's moons. The feature that truly sets Saturn apart is its spectacular ring system. These rings consist of billions of fragments of ice that reflect sunlight with remarkable brightness. The total radius of the rings extends to roughly 45,000 miles. Yet their thickness is astonishingly small, only about 1.6 miles. Scientists believe these rings may be the remains of a former moon that was torn apart by Saturn's powerful gravity. Uranus is a blue planet located about 1.8 billion miles from the Sun. The only spacecraft that has ever closely approached Uranus was Voyager 2. As mentioned earlier, Uranus appears blue, or more precisely, blue with a faint green tint. The color comes from methane in the planet's atmosphere, which absorbs red light and reflects blue wavelengths back into space. The core of Uranus is believed to consist largely of icy materials, and temperatures in the upper atmosphere can drop to around -371 degrees Fahrenheit. Winds on Uranus can reach speeds of up to 560 miles per hour. For this reason, Uranus is often referred to as an ice giant. Another unusual feature of Uranus is that it rotates on its side. Its axis is tilted so dramatically that the planet essentially rolls along its orbit around the Sun. Voyager 2 captured two well-known images of Uranus. One showing the planet as the human eye might see it, and another enhanced with artificial colors and contrast to reveal atmospheric structure. Even today, we know relatively little about Uranus. The images suggest that it possesses a faint ring system somewhat similar to Saturn's, though far dimmer. The planet is also surrounded by 23 known moons, many of which appear to be heavily covered in ice. In the future, scientists hope that new missions will once again travel to Uranus and finally reveal the deeper secrets of this distant world. Uranus may soon become one of the main focuses of NASA. Scientists are discussing the possibility of sending a new spacecraft to this distant planet in order to study its atmosphere, rings, and icy moons in greater detail. The last planet in our solar system is Neptune. Neptune is located about 2.8 billion miles from the Sun, and it cannot be seen from Earth with the naked eye. The camera of the Voyager 2 spacecraft captured Neptune and its moon Triton together in a beautiful crescent phase. This elegant photograph of the icy giant and its cloud-covered moon was taken shortly after the spacecraft's closest approach in the year 1989. Because of the angle from which the picture was taken, Neptune appears to have lost some of its usual deep blue color. Neptune is slightly smaller than its neighbor Uranus, but its mass is greater. In another image, we can clearly see thin, feather-like clouds floating high in the planet's atmosphere. Most of Neptune itself is composed of invisible hydrogen and helium gases. This distant world also has the most powerful winds in the entire solar system. Some of these winds reach speeds of about 1,240 miles per hour. In such conditions, it would be impossible for anything to walk on the surface, even if a surface existed. Scientists also believe that deep within Neptune's atmosphere, the extreme pressure and temperature may cause carbon atoms to crystallize into diamonds beneath the cloud layers. This is our home. This is our solar system. Every day, science moves forward. New images arrive. New discoveries are made. And our understanding slowly grows. Recently, the first images were captured by the new James Webb Space Telescope. In one of those early photographs, we can see only a few nearby stars. But more importantly, the image also reveals countless distant galaxies scattered across the darkness of space. The powerful technologies aboard the James Webb Telescope are opening an entirely new era in the study of the universe. Space itself is a miracle that humanity has been studying for thousands of years. And I hope that today you discovered something you were searching for. As the great physicist Stephen Hawking once said, he was not certain that the human race would survive another 1,000 years unless it found a way to expand beyond Earth and into space. There are many possible scenarios in which life on a small planet could disappear. But I remain optimistic. One day humanity will almost certainly reach the stars. To begin imagining that future, we first need to understand the enormous distances that separate us from even our closest neighboring stars. To measure this, we can compare those distances with the fastest spacecraft ever built by humans. One such spacecraft was Helios 2, a probe designed to study the Sun. It reached a speed of about 157,000 miles per hour, which is roughly 0.023% of the speed of light. That speed is incredibly impressive by human standards. Imagine that a spacecraft carrying all the necessary equipment to colonize a new world is already prepared and waiting for launch. Our destination is the Alpha Centauri system. 3, 2, 1. Do not worry. There is nothing wrong with your internet connection. The image remains almost completely unchanged. Even though we are now traveling faster than any machine humanity has ever created, on the cosmic scale, we are barely moving at all. At this speed, it would take us roughly 18,000 years to reach the nearest star system. That is the true scale of the universe. Only when we begin to understand these enormous distances can we appreciate how important it is to study our cosmic neighborhood carefully. If humanity ever hopes to wake up beneath the light of another sun, the cost and the risks are far too great to explore space blindly. For this reason, Alpha Centauri became one of the first nearby star systems to be studied in detail. Observers first noticed its primary stars, or more precisely, a pair of stars known as Alpha Centauri A and Alpha Centauri B. Both of these stars are similar to our own Sun and are classified as yellow dwarf stars. To the naked eye, they appear as a single bright point of light. the third brightest star visible in the night sky. This star system has fascinated humans since prehistoric times. It was observed by ancient civilizations, including the Sumerians and the Egyptians, and it was even mentioned in the writings of the astronomer Ptolemy. However, systematic scientific study of the system only began in the year 1915. That was when the British astronomer Robert Innes discovered a third star within the Alpha Centauri system. This faint star was a red dwarf, and it was given the name Proxima Centauri. To this day, it remains the closest known star to our Sun. The detailed exploration of our nearest stellar neighbor began at roughly the same time that the golden age of science fiction was emerging. As a result, Alpha Centauri quickly became a central location in countless stories about space exploration. It appeared in novels, films, music, and art. Writers imagined distant civilizations developing under the light of another sun. From the works of the Strugatsky brothers to the films of James Cameron, the idea of life around Alpha Centauri captured the imagination of generations. Because it is so close to us, many people began to imagine that Alpha Centauri might host extraterrestrial life. Yet reality often turns out to be more complicated than our hopes. As scientists began actively searching for exoplanets, a new wave of excitement appeared. Researchers discovered signals and indirect evidence suggesting that planets might exist around distant stars. In the Alpha Centauri system, astronomers initially detected two possible planets known as Alpha Centauri B-flap and Alpha Centauri BC. Unfortunately, after further analysis, both candidates were found to be unlikely places for life as we understand it. For a time, the possibility of habitable worlds in this system seemed to disappear. Everything changed again in the year 2016. After many years of careful observation, scientists finally confirmed the existence of a real exoplanet within the Alpha Centauri system. Even more exciting, this planet was orbiting our nearest stellar neighbor, Proxima Centauri. The newly discovered world was named Proxima Centauri b. This planet lies approximately 4.22 light-years away from Earth. Its discovery was remarkable because the planet's mass is only about 1.1 times the mass of Earth. Detecting such a small world required extremely precise measurements. Astronomers confirmed its existence by observing tiny changes in the radial velocity of the star as the planet orbited around it. But the surprises did not end there. Proxima Centauri b continued to intrigue researchers with unexpected observations. In April and May of the year 2019, the Parkes Observatory in Australia recorded unusual radio signals lasting for nearly 30 hours. The signal appeared to originate from the direction of Proxima Centauri at a frequency of approximately 982 MHz. Determining the origin of such a signal is extremely complex. According to the official scientific explanation, the shift in the signal's frequency matched the orbital motion of Proxima Centauri b. Then the signal suddenly disappeared. A second attempt to detect it again in the year 2020 failed. Later analysis suggested that the probability of an intelligent species existing in the nearest star system and producing detectable radio signals was extraordinarily small. The likelihood was estimated to be roughly 10 to the power of -8. In other words, the signal was almost certainly not artificial. At the same time, astronomers have been studying Proxima Centauri itself with powerful radio telescopes such as the Atacama Large Millimeter Array. This small red dwarf star is extremely active. It frequently produces enormous stellar flares. During one observed event, the brightness of a flare increased nearly 1,000 times within about 10 seconds and continued for roughly 2 minutes. Unfortunately, this level of activity suggests that Proxima Centauri b would be exposed to extremely intense radiation. Such radiation could easily strip away any atmosphere that might once have existed around the planet. Without an atmosphere, life as we know it would struggle to survive. Another challenge is the planet's extremely short orbital period. Proxima Centauri b completes one orbit around its star in only about 5.12 Earth distances. This means the planet is extremely close to its star. Even though Proxima Centauri is a relatively cool red dwarf, it still emits enough radiation to make the surface environment very harsh. Liquid water would have difficulty remaining stable under such conditions. However, the discoveries around Proxima Centauri did not stop there. Using the espresso spectrograph mounted on the Very Large Telescope operated by the European Southern Observatory, scientists continued studying the system between the years 2020 and 2022. During these observations, they detected evidence of another extremely small object orbiting the star. Eventually, this object was confirmed to be another planet, now known as Proxima Centauri d. It was discovered using the same radial velocity technique that revealed Proxima Centauri b. This newly discovered planet is one of the most intriguing small worlds yet found near our solar system. Its radius is estimated to be roughly 1/5 that of Earth, while its mass is about twice the mass of Mars. Scientists are still studying the planet in order to understand its environment and whether it could potentially support any form of atmosphere. Even if Proxima Centauri d ultimately turns out to be uninhabitable, its discovery remains extremely important. It shows that our nearest neighboring star system contains multiple planets. This means that nearby stellar systems may be filled with many more worlds waiting to be discovered. But what do scientists mean when they speak about the limits of our current discoveries? At the moment, astronomers mainly rely on two primary methods for finding exoplanets. The most widely used method is known as the transit method. In this technique, telescopes observe stars for long periods of time, searching for tiny but regular decreases in brightness. When a planet passes in front of its star from our point of view, it blocks a small portion of the star's light. That slight dimming can reveal the presence of an orbiting planet. Another more complex technique is called Doppler spectroscopy, also known as the radial velocity method or sometimes the wobble method. When two large objects such as a star and a planet are connected by gravity, the planet does not simply circle the star like a ball on a string. Instead, both bodies orbit around a shared center of mass called the barycenter. For example, the barycenter of our solar system lies slightly outside the surface of the Sun. Because of this shared motion, the Sun performs a tiny wobble in space. That motion changes the wavelength of the light we observe from the star. When the star moves away from us, the light waves become slightly stretched. And when it moves toward us, the waves become slightly compressed. This phenomenon is known as the Doppler shift. By measuring these periodic changes, astronomers can detect the presence of orbiting planets. These techniques are quite effective when searching for large planets. Bigger planets block more starlight or cause stronger gravitational wobbles in their stars. But discovering small Earth-sized planets such as Proxima Centauri b is much more difficult. The statistics make this clear. Among the thousands of planets currently listed in the NASA Exoplanet Archive, only a small number have masses smaller than Earth. In most cases, we detect the giant worlds first, even though smaller rocky planets may actually be more suitable for life. So, what needs to change in the near future? Many astronomers believe the answer lies in one extraordinary instrument: the James Webb Space Telescope. The launch of this powerful new observatory was followed closely by the entire scientific community and by millions of people around the world who care about astronomy. It has the potential to revolutionize not only our understanding of astronomy, but our understanding of how the universe works as a whole. In addition to detecting and studying the light from the very first galaxies, one of the most important tasks facing the James Webb Space Telescope is the search for habitable exoplanets. The images captured by James Webb should be detailed enough for us to detect the presence or absence of an atmosphere on Proxima Centauri b. Why does that matter so much? Because if the planet has an atmosphere, winds within that atmosphere would redistribute heat from the hot side of the planet to the cooler side. That means we could measure how much heat the planet radiates in the infrared as it moves along its orbit. Depending on its position, we would often be looking more toward its cooler side. If an atmosphere exists, the heat would be spread more evenly across the planet, and the fluctuations in temperature along the orbit would be much smaller. On the other hand, If the planet has no atmosphere, the heat radiated in our direction would change dramatically as the planet moves. In other words, for the first time in the history of astronomy, we may have a chance to directly study planets beyond the solar system in far greater detail than ever before. This opens an entirely new world of possibilities. We may be able not only to detect the existence of an atmosphere, but also to identify its composition. For example, James Webb could search for signs of ozone. Ozone absorbs certain frequencies of infrared light, leaving clear gaps or dark lines in a spectrum. James Webb can record those spectral fingerprints. Imagine for a moment that a hypothetical alien civilization were observing Earth from far away. If they detected distinct ozone lines in Earth's spectrum, they could infer that our planet has an ozone layer, and therefore oxygen in the atmosphere, one of the key ingredients that makes life possible. In the same way, we may be able to make similar conclusions about distant worlds. Furthermore, James Webb can help determine a planet's axial tilt, as well as its size relative to its parent star. All of these are extremely important parameters. And in the years ahead, scientists will learn how to use them more effectively as the telescope continues its mission at Lagrange point L2. Before revealing the deepest secrets of the universe, the telescope had to be carefully calibrated and prepared for its first observations. But when we talk about James Webb, we are talking about the near future of exoplanet science. And what if we look a little farther ahead? What might await us in a more distant, but still imaginable, future? Travel to these worlds, of course, remains the territory of science fiction for now, with its warp drives and hyperspace engines. But there is one real project that dares to think seriously about interstellar flight. It is called Breakthrough Starshot. Breakthrough Starshot is an ambitious initiative aimed at creating ultralight spacecraft equipped with light sails. Small probes that could one day travel to the Alpha Centauri system in roughly 20 to 30 years. To do that, they would need to reach speeds of about 15 to 20% of the speed of light, propelled by enormously powerful lasers. The idea attracted the attention of many space enthusiasts, including Mark Zuckerberg, and became one of the boldest visions for the future of exploration. The project involves several stages. First, a larger carrier system would deliver a group of tiny probes into orbit. Then comes the most difficult step of all: creating a global network, almost a forest, of extremely powerful lasers positioned around Earth. Because our planet rotates, many laser arrays distributed around the world would be needed to continuously accelerate the tiny spacecraft. Each sail, only a few meters across, would be pushed by beams of astonishing power. The energy involved would be enormous. For comparison, all existing cryptocurrency mining in the world consumes well over 100 terawatt-hours of electricity every year. Even so, the project's founders, Yuri Milner and the late Stephen Hawking, envisioned sending as many as 1,000 miniature probes toward Alpha Centauri. The estimated cost, somewhere between $5 and $10 billion, may sound suspiciously optimistic, especially considering that the James Webb Space Telescope itself cost around $10 billion. But in terms of scientific value, these two projects may one day stand side by side. Just imagine what it would mean if humanity could send probes to another star. That could become the final great rehearsal before any true attempt to colonize distant worlds. Such probes could provide detailed information about planets we may want to visit in the far future. And perhaps, more importantly, they could help answer one of the most profound questions ever asked. How many worlds are truly out there? And how likely is life beyond Earth? Life as we know it, and perhaps even stranger forms of life that today exist only in imagination. That brings us to an even more fascinating possibility: the idea of non-standard life forms on exoplanets. Earlier, we mentioned that Proxima Centauri is a highly active star, flaring every 10 to 30 hours and bombarding Proxima Centauri b with intense ultraviolet radiation and powerful charged particles. These conditions would be deadly to almost any life form on Earth. Yet the possibility of alien life is not completely ruled out. In theory, life on Proxima Centauri b could still exist despite these violent bursts of radiation. Some organisms might survive by hiding beneath the surface or deep underwater, sheltered within natural cavities or underground reservoirs. And there is another possibility that makes the imagination race. The way some proteins absorb ultraviolet radiation is not yet fully understood. In theory, organisms equipped with protective proteins might be able to convert harmful ultraviolet energy into biofluorescent light at different wavelengths. Put simply, it is possible to imagine that a few feet beneath the surface of Proxima Centauri b, there could exist entire ecosystems of glowing organisms, radiating soft colors in response to their violent sun. It sounds like science fiction, but the basic idea has roots in real biology. On Earth, for example, some corals deep in the ocean contain fluorescent proteins. These proteins become photoactivated when exposed to ultraviolet radiation in the long-wave range, roughly from 315 to 400 nanometers, and also by blue light in the range of about 420 to 700 nanometers. They then re-emit that energy at longer wavelengths. If organisms on Proxima Centauri b had evolved a similar survival strategy, the planet might glow brightly at certain wavelengths, possibly even within the visible spectrum, and such a glow could, in principle, be detected by instruments like James Webb. The possibilities opened by the study of exoplanets are difficult to overstate. We are not simply moving closer to answering one of the greatest questions in history. Are we alone in the universe? We are also expanding the future horizons of humanity itself. Every new world we discover broadens our sense of what life could be, where it could exist, and how far our species may one day travel. Time will tell whether Proxima Centauri b is merely the first of trillions of similar worlds, or whether it is an unusual exception. For now, while we remain alone as far as we know, it is up to us to keep asking the questions. And in the conquest of space, our greatest allies remain what they have always been: human curiosity and human perseverance. It is difficult to imagine anyone who has seriously reflected on the scale of outer space and not felt at least a trace of that deep, bone-chilling awe. The endless emptiness. The terrifying black holes capable of swallowing matter itself. The trillions of strange exoplanets so distant and so mysterious that they seem forever beyond reach. Today we are going to look at 6 incredible exoplanets. Worlds with conditions so extreme that they resemble visions of hell drifting silently through space. Isolated, hostile, and in some cases so strange that they even manage to fool astronomers. First on the list is Corot 7b. This is an exoplanet with a form of precipitation so exotic that no umbrella would help you, unless it were made of titanium. Corot 7b is a planet where it literally rains rocks. This unusual world is a little more than 1.5 times the size of Earth, and its age is estimated at about 1.5 billion years. In cosmic terms, it is relatively nearby, lying about 489 light-years from us. Back when it was first discovered, scientists considered it the first rocky exoplanet that truly resembled Earth in composition. But any similarity ends there. Today it is classified as completely uninhabitable, with essentially zero chance of life as we understand it. If you were somehow able to stand on this planet and watch the sunrise, it would almost certainly be the last thing you ever saw. The rays of its parent star, located in the constellation Monoceros, would turn the surface into an inferno the moment that sun rose above the horizon. Corot 7b orbits about 60 times closer to its star than Earth does to the sun. As a result, the star would appear roughly 360 times larger in the sky than our sun appears to us. On the day side of the planet, temperatures can reach around 4,700 degrees Fahrenheit, or about 2,600 degrees Celsius. That is hot enough to melt and even vaporize rock. And then something extraordinary happens. The vaporized rock rises into the atmosphere, cools, condenses, and forms tiny fragments of stone. These then fall back to the ground as literal rock rain. Some theoretical models suggest that vast oceans of lava may cover parts of this planet. The situation becomes even more extreme because Corot 7b is most likely tidally locked. One side permanently faces the star, a world of fire and vaporized stone, while the other side remains in perpetual darkness. On that dark side, temperatures may plunge to around minus 390 degrees Fahrenheit, or roughly minus 235 degrees Celsius. Astronomers believe Corot 7b may have begun its life as a gas giant, perhaps 100 times more massive than Earth. But as it spiraled closer and closer to its star, its outer gaseous layers were gradually stripped away by stellar radiation and solar wind until only the rocky core remained. That is the tragic history of Corot 7b, and its present state is no less terrifying. We can only hope that the brutal conditions of that world have not put you off, because the next planet on our list is also horrifying, although in a very different way. Although the next world does not have the same inferno-like conditions, it absolutely belongs in the category of places you would never want to approach to get anywhere near J1407b. You would first have to cross an almost endless belt of rock and ice. It is tempting to compare this enormous gas giant to Saturn, because it too is surrounded by rings. But the comparison quickly breaks down. The rings of J1407b are not merely larger than Saturn's, they are on an entirely different scale. These rings are about 200 times wider than the main rings of Saturn. Saturn has 3 major rings. J1407b appears to have around 30. Together they span more than 110 million miles. Pause for a moment and let that number sink in. That is roughly 20% greater than the distance from Earth to the Sun, which is about 93 million miles, or 1 astronomical unit. By comparison, the radius of Saturn's largest ring is only about 180,000 miles. Ring systems on this scale most likely form through catastrophic destruction. In other words, they may be the remains of shattered moons. So what might have happened here? Scientists estimate that J1407b may have a mass somewhere between 10 and 40 times that of Jupiter. That is such a massive body that its gravity could have torn nearby satellites apart. There is another possibility as well. Some researchers suggest that J1407b may not be a gas giant at all, but a failed protostar. An object that began to form like a star but never gained enough mass to become a brown dwarf. Even now, there is no complete consensus in the scientific community about how this object should be classified. One argument in favor of the failed star idea is that the object appears to orbit its host star in a way that does not fully resemble the motion we see in a typical binary star system. What is truly astonishing is that this vast ring system, despite its immense size, has a total mass of only about 7.34 times 10 to the 21st tons. That may sound enormous, but it is actually comparable to Earth's mass on the same order of magnitude. In the history of J1407b, there may have been many violent and extraordinary events. One of them could have been a collision with a moon whose mass lay somewhere between Earth and Mars. The possible trace of such a collision may still be visible today as a large gap within the ring system. In fact, Those gaps helped scientists discover this world in the first place using the transit method. By studying how the ring system blocked light from its star, researchers were able to infer not only the size of the object, but also the structure and position of its rings. If Saturn's rings already seem magnificent to us, then the view from J1407b, or from one of its lost moons, would be almost beyond imagination. It would be the kind of sight that would leave you speechless. Now let us move a little closer to home. About 80 light-years from the Sun, there exists an object that may deserve to be called one of the loneliest worlds in the universe. Its name is PSOJ 318.5-22. And what makes it so extraordinary is that it does not orbit a star at all. PSOJ 318 belongs to a rare class of worlds known as rogue planets, sometimes called orphan planets or nomad planets. These are worlds that have been ejected from their original planetary systems and now drift alone through the darkness of interstellar space. Paradoxically, the absence of a bright host star actually made this object easier for astronomers to study. Without the overwhelming light of a nearby sun, they were able to observe the faint glow of the planet directly. Using the Pan-STARRS survey telescope and infrared observations, astronomers found that this object is about 8 times more massive than Jupiter and far brighter than expected. Variations in its brightness revealed that it completes one full rotation in only about 5 hours. They also showed that the planet has multiple layers of thick and thin clouds, with temperatures around 1,470 degrees Fahrenheit. Observations from the European Southern Observatory in Chile allowed astronomers to produce one of the first approximate weather forecasts ever made for a body beyond the solar system. And the forecast is not inviting. A cloudy but extremely hot atmosphere, dust storms moving at several times the speed of sound, and perhaps even molten iron rain. The estimated age of this lonely world is about 12 million years. Scientists are still unsure how such rogue planets form. Some may be failed stars. Some may be massive gas giants. Others may be ordinary planets that were violently thrown out of young planetary systems after gravitational encounters with larger worlds. Once ejected, they drift alone until perhaps one day they are captured by another star system. That uncertainty creates a problem of classification. Many astronomers describe objects like PSOJ 318 as sub-brown dwarfs, suggesting that they occupy a strange middle ground. Not quite a star, but not quite a planet in the familiar sense either. And although scientists have already identified several rogue planets, this is still only the beginning. In the future, we will almost certainly be astonished by what these wandering worlds reveal. Now we move on to witness a slow cosmic death. A place where we encounter WASP-12b, a planet that scientists have bluntly labeled doomed. Life on its surface would be impossible for many reasons. But the most dramatic is this. The planet is literally being torn apart by its own star. Piece by piece, its material dragged out into space. WASP-12b is a gas giant with a radius roughly twice that of... But unlike Jupiter, which takes nearly 12 Earth years to orbit the Sun, WASP-12b completes one full orbit around its star in about a single day. That extraordinary speed creates immense tidal forces. If current calculations are correct, those forces have stretched the planet out of shape so severely that it may be closer to an egg than a sphere. Astronomers estimate that this world cannot survive forever under such stress. In at most 10 million years, it may be completely destroyed, reduced to a cloud of gas and dust that will gradually be absorbed by the star. Even more remarkable, the planet appears to be exchanging matter with its host star. Until this discovery, scientists believed that such mass transfer was something that happened only between stars. WASP-12b became the first confirmed exoplanet where this phenomenon was observed. This gravitational torture also heats the planet to extreme temperatures. reaching around 4,100 degrees Fahrenheit. Under such conditions, any possibility of life as we know it is effectively erased. Yet despite this hostility, the Hubble Space Telescope later used spectroscopy to detect evidence of water in the planet's environment. An astonishing finding under such brutal conditions. Another surprising possibility is that if this world has any solid interior at all, it may contain graphite and even diamonds. The reason is the extremely high concentration of carbon believed to exist in the planet's composition. Some media outlets even nicknamed it the Diamond Planet. However, many scientists suspect that most of that carbon exists not in a solid surface, but in the atmosphere, mainly in the form of carbon monoxide and methane. Research published in 2012 also raised the possibility that WASP-12b may have a moon, sometimes referred to as WASP-12b1. Its estimated radius would be about 6.4 times Earth's radius, which would still make it only around 3 times smaller than the planet itself. What conditions might exist on such a moon? We can only guess, but they are unlikely to be any gentler than those on its disintegrating parent world. And now we come to a planet wrapped in genuine mystery. We are talking about Fomalhaut b, once known by the name Dagon, a distant world that may never have existed at all. Intrigued? Then let us go back to the beginning. In the year 2004, the Hubble Space Telescope discovered a vast cold debris disk of gas and dust around Fomalhaut, one of the brightest stars in the night sky and located only about 25 light-years away. The star itself is roughly twice the size of the Sun. Almost immediately, theories began to circulate. Perhaps there was a giant planet hidden within that disk, maybe as large as 3 Jupiters. Yet at the time, no one had actually seen such a planet. Then the object now called Fomalhaut b began to behave in a very strange way. Its apparent speed changed over time. In 2008, the announcement that an image of the object had been captured caused a sensation in the scientific world. But the more astronomers studied it, the stranger it became. The object appeared much smaller than originally expected, with a mass somewhere between Earth and Mars. Its faint infrared glow and its inability to significantly shape the debris ring around Fomalhaut suggested that it was not a massive planet at all. Even stranger, the object became dimmer as it appeared to grow larger, and its motion did not match the predicted orbit. Astronomers had reached an impasse. Nothing like this had been seen before. Then in 2014, the mystery deepened even further. The object disappeared. Beginning in 2008, it had gradually expanded and faded until eventually it vanished altogether. These observations contradicted almost everything astronomers thought they knew about exoplanets. So they returned to the data and came to a radical conclusion. Dagon, or Fomalhaut b, may never have been a planet in the first place. Instead, the object may have been a slowly expanding dust cloud created by a violent collision between 2 large asteroids. Or perhaps even 2 small protoplanets. That alone would be an extraordinary event, because collisions on that scale are believed to be extremely rare. According to this interpretation, the collision likely happened just as Hubble happened to be looking at the region in 2004. As the dust spread outward, the object would naturally appear larger and dimmer over time. Its unusual motion would also make sense if it were a cloud of debris rather than a compact planet. So, a series of remarkable coincidences confused astronomers and gave rise to one of the strangest stories in exoplanet science. The story of a world that did not look like a planet, did not move like a planet, and may not have been a planet at all. Although Fomalhaut b eventually lost its exoplanet status, there is no reason to be disappointed. There are thousands of confirmed worlds out there, and many of them are still waiting to surprise us. And that brings us to a very different kind of world. one that may have witnessed the early history of the universe itself, Captain B lies only about 13 light-years away. But its age is estimated at roughly 11.5 billion years. That makes it more than twice as old as Earth, and only about 2 billion years younger than the universe itself. We are not fascinated by this world only because of its age, but because of what may have unfolded there over such an immense span of time. Its host star, Captain's star, is classified as a red subdwarf. Because of its age, it emits an unusual spectrum of light. The star radiates about 250 times less light than the Sun and has only about 1/4 of the Sun's mass. Even so, scientists believe Captain B may lie within the star's habitable zone, despite orbiting very close to it, only about 0.168 astronomical units away, which is even closer than Mercury is to the Sun. In theory, temperatures on the planet could allow liquid water to exist. Some estimates suggest the surface temperature may vary between about -58 degrees Fahrenheit on the dark side and around 50 degrees Fahrenheit on the side facing the star. These properties affect what scientists call the Earth Similarity Index. At the time this script was written, Captain B had an Earth Similarity Index of around 67. Comparable to several other major candidates in the search for extraterrestrial life. Of course, age alone does not guarantee that life exists, but it does increase the odds that life could have had enough time to emerge. The origin of life is a slow and complicated process. If 4.5 billion years were enough for life on Earth to evolve to the point where you are watching this video right now, then perhaps 11.5 billion years on Captain B could have been enough for microorganisms. Or maybe something more to develop long ago. Perhaps ancient life has existed there for ages, unnoticed, to generations silent, and distant. And from there, our journey turns toward one of the strangest and most feared objects in the cosmos. What do we really know about black holes? They are regions of space-time where gravity becomes so strong that nothing in the surrounding area, not even light, can escape once it crosses the threshold. For a long time, black holes were treated as cosmic monsters, devouring everything around them and perhaps even destroying information itself. But how accurate is that image? What if black holes can do more than destroy entire star systems? What if, under the right conditions, they can also help create them? To understand that possibility, we first need to look more carefully at what black holes really are. Let us begin with the terminology itself. Are these objects truly holes? And are they really black? If you asked a physicist, an astronomer, or a mathematician, you would likely get answers that are similar in spirit but very different in approach. That is because inside a black hole, the laws of physics as we know them no longer behave in familiar ways. According to Einstein, gravity in such an object warps space-time so intensely that it is almost as though reality itself tears. So how does a black hole form? And can any star become one? Scientists are still debating the exact mechanisms behind the formation of black holes. But the most widely accepted explanation is gravitational collapse. According to this idea, a black hole can form when a star with a mass roughly between 2.5 and 5.6 times the mass of the Sun runs out of fuel and collapses under its own gravity. And yet, once the black hole forms, it may be only a few dozen miles across. That is one of the strangest facts in all of astrophysics. If the Sun were somehow turned into a black hole, its radius would shrink to only about 1.9 miles. Compared with its current radius of roughly 432,000 miles. Why do these numbers matter so much? Because they point to a very important concept: the compression limit at which an object becomes a black hole. This limit is called the Schwarzschild radius, named after the astronomer Karl Schwarzschild, who first described this relationship. In principle, Any object in the universe could become a black hole if it were compressed enough. The Sun would need to be squeezed down to a radius of about 1.9 miles. Earth would need to be compressed to about 0.35 inches. Just a little larger than a grain of rice or the ball at the tip of a ballpoint pen. It is a deeply unsettling thought. In theory, the objects around you could all become black holes, if only they were crushed far enough. There are two main ways physicists interpret black holes. One comes from general relativity, and the other comes from quantum mechanics. According to general relativity, a black hole is surrounded by a spherical boundary beyond which neither light nor matter can escape. This boundary is called the event horizon. It is the point where gravity becomes so overwhelming that escape is no longer possible. Once you cross the event horizon, there is no returning. If we could somehow travel inside a black hole, we would find that space-time becomes more and more distorted as we approach the center. At the very center, according to the classical theory, space-time becomes infinitely warped. Scientists call this point the gravitational singularity. At that location, the familiar concepts of space and time seem to break down completely, and the known laws of physics no longer work in any meaningful way. Of course, a black hole does not really have a surface in the usual sense. The event horizon is not a wall you can touch. It is simply a boundary in space-time. In fact, you cannot even describe a black hole as an ordinary object with a clear shape or a physical exterior. The easiest analogy is this. Imagine you are in a completely dark room and you accidentally walk through a doorway into another room that is exactly the same. You do not feel the doorway itself. You simply cross it without noticing. Falling into a black hole would be like that. There is no solid border in front of you. There is only a region where mass has warped space-time so severely that nothing can come back once it passes through. Everything that enters remains forever beyond the horizon. This leads to one of the most profound questions in modern physics. What is actually inside a black hole? What would an observer experience while falling in? And what would that look like to someone watching from the outside? According to relativity, the moment you cross the event horizon, reality seems to split into two very different stories. In one sense, from your own perspective, you simply continue falling inward. You would not feel the crossing itself. You would not hit anything. You would just keep moving through distorted space-time in a state of free fall. But to an outside observer, something very different happens. You would appear to slow down, freeze near the horizon, and gradually fade away. Both descriptions are valid within physics. That is part of what makes black holes so extraordinary. If the black hole were extremely large, millions of times more massive than the Sun, you might cross the horizon without immediately noticing anything unusual. But if the black hole were smaller, the difference in gravity between your head and your feet would become enormous. You would be stretched out by tidal forces into a long, thin shape, like a strand of spaghetti. That is not just a dramatic metaphor. It is the actual scientific term for the process. Spaghettification. For the sake of this thought experiment, let us imagine that we are falling into a supermassive black hole. One large enough that we do not die instantly. In that case, we would drift inward in a relatively smooth descent toward the singularity. From our own point of view, the journey would continue. But from the outside, we would seem to vanish at the edge of the hole. So who is right? According to modern physics, both perspectives are right in different ways. And this is where the problem becomes even deeper. According to Stephen Hawking's work, black holes are not entirely black. Over unimaginable periods of time, they can slowly lose mass and evaporate. Near the event horizon, pairs of so-called virtual particles can appear. In rare cases, one particle falls into the black hole while the other escapes into space as radiation. This is what we call Hawking radiation. Through this process, a black hole can gradually lose mass. For a supermassive black hole formed through the merger of many others, the evaporation timescale would be almost incomprehensibly long. Around 10 to the power of 100 years. That number is so vast that it dwarfs the age of the universe itself. But in theory, the black hole would eventually disappear. And this creates a paradox. If something falls into a black hole and the black hole later evaporates, what happens to the information carried by the original object? According to the laws of quantum physics, information cannot simply be destroyed. But if matter enters a black hole, is crushed, heated, and eventually lost, then it seems as though the information about that matter disappears forever. This conflict is known as the black hole information paradox. Fortunately, physicists have made progress toward understanding it, although the answer is still not complete. One important idea comes from the so-called no-hair theorem. In simple terms, this theorem says that an ordinary non-spinning, non-charged black hole is defined only by a very small number of properties, mainly its mass. If an object falls in, its detailed structure no longer seems to matter. The black hole only gains mass. In that sense, black holes of the same mass would appear indistinguishable from one another. That is why physicists say black holes have no hair. They mean black holes do not preserve the visible complexity of whatever formed them. But string theorists proposed a more subtle solution. According to string theory, all matter is made not of point particles, but of tiny vibrating quantum strings. To picture this, imagine the strings of a musical instrument. They can vibrate, and oscillate in different ways. In string theory, reality itself is built from objects like that. From this perspective, a black hole may not be an empty region with a singularity hidden inside. Instead, it may be something more like a fuzzball, a dense, tangled ball of quantum strings vibrating according to the laws of quantum mechanics. In this picture, the black hole is not a hollow place filled with crushed particles. It is more like a cosmic knot, a ball of fundamental strings woven together so tightly that what we perceive as the black hole emerges from that structure, and in this theory, there may be no singularity at all. There may not even be a true inside in the classical sense. Space-time as we normally imagine it may simply stop existing beyond a certain point. That possibility is one of the most radical ideas in modern theoretical physics. And it suggests that black holes may be far stranger than even Einstein imagined. Scientists are still debating the mechanisms behind the appearance of black holes. But the most widely accepted explanation is gravitational collapse. According to this idea, a black hole can form when a massive star exhausts its nuclear fuel and collapses under its own gravity. Typically, this happens when the star's mass is somewhere between 2.5 and 5.6 times the mass of the Sun. And yet, once the collapse is complete, the resulting black hole can be astonishingly small, often only a few dozen miles in diameter. To understand how extreme this compression is, consider our own Sun. If the Sun somehow became a black hole, its radius would shrink to only about 1.9 miles. Compare that to its current radius of roughly 432,000 miles. These numbers are not random. They are defined by something known as the Schwarzschild radius. This concept was first described by the astronomer Karl Schwarzschild, who discovered the exact relationship between an object's mass and the radius at which it would become a black hole. In theory, any object in the universe could become a black hole if it were compressed enough. The Sun would need to shrink to about 1.9 miles in radius. Earth would have to be compressed to about 0.35 inches, roughly the size of a grain of rice, or the tiny ball at the tip of a ballpoint pen. It is a strange and unsettling idea. In principle, the objects around you could all become black holes, if only they were squeezed tightly enough. Physicists generally describe black holes using two major frameworks. One comes from Einstein's theory of general relativity. The other comes from quantum mechanics. According to general relativity, a black hole is surrounded by a spherical boundary known as the event horizon. This is the point beyond which nothing can escape, not even light. Once an object crosses the event horizon, there is no possible path back out. It is the ultimate point of no return. If we somehow managed to travel inside a black hole, space-time itself would become more and more distorted the closer we moved toward the center. At the very center lies what scientists call the gravitational singularity. At this point, space-time is predicted to become infinitely curved. The normal concepts of space and time stop making sense, and the known laws of physics break down completely. Interestingly, a black hole does not actually have a surface in the traditional sense. The event horizon is not a wall or a physical barrier. It is simply a boundary in space-time. Imagine walking through a completely dark room. Suddenly, you pass through a doorway into another room that looks exactly the same. You would not feel the doorway. You would simply cross it without noticing. Falling into a black hole would be similar. There is no physical surface to collide with. Just a region of space where gravity has warped space-time so severely that escape becomes impossible. Everything that enters this region remains forever beyond the horizon. This leads to one of the most fascinating questions in modern physics. What actually happens inside a black hole? What would a falling observer experience? And what would an outside observer see? According to relativity, these two perspectives are dramatically different. From the viewpoint of someone falling into the black hole, nothing particularly special happens at the moment of crossing the event horizon. You would simply continue falling inward through distorted space-time. But to someone watching from far away, you would appear to slow down as you approach the horizon. Eventually, you would seem to freeze in place, fading slowly from view. Both descriptions are correct within the framework of modern physics. If the black hole were extremely large, millions of times more massive than the Sun, you might cross the horizon without immediately noticing anything unusual. However, for smaller black holes, the difference in gravitational pull between your head and your feet would become enormous. You would be stretched into a long, thin shape by tidal forces. Scientists actually have a name for this process: spaghettification. For the sake of imagination, let us assume we fall into a supermassive black hole large enough that this stretching effect is minimal at first. From our own perspective, we would continue falling inward toward the singularity. Meanwhile, observers outside the black hole would see us slowly vanish near the horizon. So who is correct? According to physics, both perspectives are valid, and this is where the puzzle deepens. Stephen Hawking showed that black holes are not completely black. Over extremely long periods of time, they slowly lose mass through a process called Hawking radiation. Near the event horizon, pairs of virtual particles can spontaneously appear in empty space. Occasionally, one of these particles falls into the black hole while the other escapes into space. To distant observers, this escaping particle appears as radiation emitted by the black hole. Over time, this radiation causes the black hole to slowly lose mass. For a supermassive black hole, the time required to completely evaporate is almost unimaginably long, around 10 to the power of 100 years. That number is vastly larger than the current age of the universe. But this process creates a profound paradox. According to quantum physics, information cannot be destroyed. Yet if objects fall into a black hole and the black hole eventually evaporates, the information about those objects appears to vanish. This contradiction is known as the black hole information paradox. One proposed solution comes from string theory. In this framework, matter is not made of point-like particles, but of tiny vibrating quantum strings. Using this idea, some physicists propose that black holes may actually be something called fuzzballs. Instead of containing a singularity hidden inside an empty region, a black hole might be a tangled ball of vibrating quantum strings. In this picture, there is no true interior and no singularity in the classical sense. Space-time itself may simply dissolve into this dense quantum structure. A black hole would not be an empty cosmic hole. It would be more like a tightly wound ball of fundamental strings, vibrating according to the deepest laws of quantum mechanics. And if that idea turns out to be correct, then black holes may not destroy information at all. They may simply hide it within the deepest fabric of reality. And so we arrive at a strange place in our understanding of the universe. For centuries, humanity searched for answers by looking outward at the stars, the galaxies, the expanding structure of space itself. We built telescopes. We measured radiation left over from the birth of the cosmos. We mapped the faint fluctuations in the cosmic microwave background, those ancient ripples still echoing from the first moments after the Big Bang. From those delicate patterns of temperature across the sky, scientists were able to estimate one of the most important numbers in cosmology, the density parameter, omega. And the answer we arrived at is surprisingly simple. Omega appears to be equal to 1, which means our universe, at the largest scales we can measure, is essentially flat. Not curved like a sphere, not open like a saddle, but balanced precisely on the edge between expansion and collapse. A universe that continues expanding, quietly, steadily, into the deep future. But once we accept that picture, a new question appears. If the universe is vast, possibly infinite, and if the laws of physics allow countless possible outcomes, then perhaps our universe is only one realization among many. Maybe somewhere beyond the horizon of our observable cosmos, there are other regions of space-time where events unfolded differently. Maybe somewhere a star formed that never ignited. Maybe somewhere an atom behaves in a way our physics cannot predict. And maybe somewhere a version of you is asking the same questions we asked tonight. Of course, these ideas remain speculative. The multiverse is not something we can easily observe, measure, or confirm. For now, it remains a hypothesis, a mathematical possibility, a philosophical extension of the equations that describe our universe. But even if the multiverse never reveals itself, the questions it raises are still valuable. Because every time we push the boundaries of what we understand, we also push the boundaries of what we are able to imagine. And perhaps that is the quiet beauty of science. Not that it gives us final answers, but that it allows us to keep asking better questions. So tonight, as the universe continues its slow expansion, galaxies drifting further apart, ancient light traveling silently across billions of years, remember that we live during a very brief moment in cosmic history. A moment when the universe is old enough for stars to shine, old enough for planets to form, and old enough for conscious minds to wonder where it all came from. Somewhere out there, the answers may exist. Or perhaps the search itself is the answer. Either way, the universe will continue unfolding its story, slowly, patiently, across unimaginable time. And for now, it's enough simply to look up and wonder. So if you're listening to this as the night grows quiet, let the questions drift away for a while. The universe will still be there tomorrow, still expanding, still mysterious, still waiting. Sleep well beneath the stars. And as always, stay curious, stay critical.